So let me introduce you now, Javier Velázquez from Telefónica. He will present us the network slice controller, which is the main feature for release 5.
Okay, so thank you for the introduction, Ricard. Yes, as you mentioned, I'm going to present in this ecosystem day the network slice controller. As some of you may know, this is one of the main features released in the latest release in TeraFlow, and it is the main component being developed in the Hackfest we are conducting these days. Also. Here at CTTC. So the idea for this presentation is, well, giving you more insights about this component with some presentation of the background that motivates the creation of this component. Then we will show the architecture that if you have participated in the Hackfest, probably you may know more or less, you have been working there. And then we will see some use cases where this component is being implemented and can be used. Okay, so going with the background and motivation, I always like to start this presentation by providing a definition of network slicing, because I think it's important to understand this concept before going into more detail. So I always like to put some examples here, different photos. For example, here you have a football stadium that it is crowded with people, and sometimes if you have gone to these kind of events, you will probably encounter problems with the mobile network being saturated of how much people it's using it. We have similar examples here in a concert full crowded of people that probably the same will happen. The mobile network would be saturated. And the last one here, this last year celebration in Cibeles in Madrid when Real Madrid won the Champions League. Probably in Canaletas this year, if you have gone there to celebrate Barcelona titles, you have experienced the same. But the same happens in all of these use cases. Here, the mobile network is oversaturated because of the people that is using it, and network slicing tries to solve this issue by providing some specific connectivity for users to reserve some resources in the network to provide them a custom connectivity with certain assurance. So 3GPP defined this term in 5G when it was released, and they provided this definition where it says that network slicing aims to provide a customized connectivity service with specific capabilities and characteristics. So the 3GPP comes here, and well, this network slicing was defined in this technical specification, the 28541. Well, they express these network slices in network resource management model. So here, the real problem that the gap that appeared here by the 3GPP is that you can see in the figure below, they didn't express how the functions in the mobile network for the end-to-end slicing were connected. They provided the slicing definitions for RAN and core components, but they did not express how these functions were connected via the transport network. So they leave that that slicing to an external transport management system. So that is one of the things that happens here, that the core and RAN is like defined, but there's a gap there in the transport network. So there it comes another standard organization that is the IETF to cover this gap, which defined in the RFC 943 a framework for network slices in networks built from IETF technology, which are the transport network. So in this way, they define a whole framework covering this use case. This is the main reason that network slicing in IETF was defined, but it is not only restricted to the mobile network use cases. It can be expanded to another use cases to use the IETF network slices in private networks or other domains. So apart from that, yeah, they defined the IETF network slices as logical partitions of a network that enable connectivity between a set of endpoints with specific characteristics such as latency, bandwidth, and so over a common underlay network. So in this definition, they define three main stakeholders for providing this slice. First of all, we have a higher level orchestrator that could be a 3GPP management system that requests the slice in the transport. Then we would have the IETF network slice controller that was defined for this purpose that could translate this request that would come in a model called network slice service to network specific configuration to a network controller that in this case we could put their TeraFlow. So going into the architecture of the network slice controller defined by IETF, they define the network slice controller that I will call NSC as a shorter name. They define it as a network controller that orchestrates the request, realization, and lifecycle control of IETF network slices. And as I showed in the previous image, it consumes in the northbound interface an IETF network slice request, and in the southbound they implement they use specific underlay technologies depending on the network controller that are feeding in the southbound. So in somehow it is kind of the link between 3GPP and IETF. So it is a component that covers both domain and try to extend this end-to-end network slicing concept defined by 3GPP. So in the architecture, it is more detailed what the IETF defined, but this is basically what I explained. There is an orchestrator sending the request that would come to the IETF network slice controller. The draft you see here, it's just a young model that it's going to become an RFC in a few time that defines this network slice service request. And as I mentioned, the network slice controller would translate this request into specific network configurations for the southbound network controllers. And this is also defining the RFC 9543. Going into more detail, this component is decomposed into modules, the mapper and the realizer. Basically, the mapper, this first component, does some kind of, it puts context into the network slice controller of the whole network. So when the request comes, the NSC obviously does not have context of the topology of the network, and it has to ask for another external component such as planner components that have more context of the network to provide a specific path for the network, and so this mapper component has this purpose. And then the realizer with the whole context of the network receives these requests and decides the proper technology for realizing the slice and triggering its realization. These technologies could be layer 2 or layer 3 VPNs, or also could be segment routing or different technologies. So if we advance, I would like to show some use cases in some national and European projects that we have implemented this, or we want to implement in the future. The first, this is a national project where we have implemented the network slash controller. The project is called 6G Blur. It's a joint effort along with CTTC and other partners, but in this particular case, what we are providing here is we are providing end-to-end slicing in a 5G mobile network where the different RAN elements and core are deployed via Kubernetes in a cloud environment. So there's this flexibility of enabling different splits in the network, and in between, in this case, in the backhaul network, we have a transport network that has been emulated with some emulation network software called DFMG, where it is connected to a control plane where we have a network controller and TeraFlowSDN, where in an automated way and from a first triggering for the customer, we configure slices via layer 2 VPNs using MPLS path selection. So in this way, we deploy 3 slices, one for control plane traffic, another one for one UPF, one user, and another slice for another user. So there are 2 different users using differentiated slice traffic. And also, it's important to remark that we have deployed this testbed between Telefónica and CTTC. So one of the users is located in Telefónica using the network, and the other one is in CTTC using the other slice. If we advance a little bit, we have another European project called 6Green, where the focus here is in the part of the wireless infrastructure manager. As the NSC, we are allocating this component in some use cases regarding green efficiency of the network. It's a European project, as its name suggests, that is focused on efficiency of the network and green efficiency. So with the network slash controller, what we are doing is deploying, let's say, green slices that by request of the customer with different green characteristics, such as efficiency of the network, carbon footprint, and other characteristics. They request for a slice of with green capabilities. So with the network slash controller, we enable green paths for traffic. So the traffic goes through, let's say, green nodes that consume less energy than others. So we are able to provide this kind of slices. And well, lastly, this is Unity 6G, a new project that we have started this January, where the network controller is also appearing here in the transport underlay network, where the idea is covering some use cases. For example, there's an important use case that we are covering with the NSC, which is the network disaster handling use case, where it tries to cover some situations such as, some things like, I don't know, a tornado or something that completely destroys the network and try to recover from this situation as fast as possible. So with this way, we could use the network slice controller to provide some specific emergency slices for these situations to make emphasis in recovering the network through the essential services. So yeah, well, this is more or less the idea that I wanted to present. So thank you very much for your time.
Okay, I have one short curiosity.
Okay.
Can you go to the previous slide?
Yes.
So in this figure, where would you locate the network slice controller?
Well, it would be located in the control sublayer operating over the transport network, and it will be collocated along with TeraFlowSDN, the NSCN TeraFlow. In fact, you see there SDN controller at the left, so it will be located there.
Thanks a lot.
Thank you.
Let's say again. That one. In the case of the city,
Yeah, TeraFlow would be located in the WIM. It's not really detailed here as this is the overall architecture in the project. But yeah, it would be focused on the wide area network. And yeah, it would be covering there some, for example, the cloud continuum wide area for the different workloads located in the cloud to provide there the connectivity with green characteristics.
Let's thank the speaker again.